So this is the video on trig equations, and so first of all, let me define what a trig equation is. So a trig equation is an equation which has some trigonometric form. So you can see that this is a trig equation because it says sine x is equal to 1/2. So there's an x, but x is not like a regular equation because x comes with a sine x. So it tells you to solve this. So what do you mean by solving? Just like a regular equation, the idea is to find the values of x which satisfies this equation. And now if you go down to here, you see another trig equation, which is what? 2 cosine x minus 1 is equal to 0. Now here they ask you to find all solutions. And then you have another trig equation here, which says to find all solutions of tangent x equals 1. So these equations are just like regular equations, except that they have some trig function in it. And notice that some equations just ask you to find the possible values of x between 0 and 2 pi, while other equations want you to find all solutions. When you're trying to solve these trig equations, there's a 3-step process. First step is to isolate the trig function on the left side. Second step is to find all solutions in the unit circle, and if step 3 is to find, if necessary, to find all solutions. Not necessarily in the unit circle, but to find all solutions. So let's take this one equation called sine x is equal to 1/2. Look at step 1. Isolate the trig function on the left hand side. So have we done that? Yeah, it's already isolated. There's nothing on the left hand side of the equation other than sine x. Okay, and now you need to find all solutions in the unit circle. So how do you do that? So let me take out a copy of the unit circle, and then we can take it from there. So here is a filled unit circle, right? So now let's get back to our problem. You need to find the places where sine x is equal to 1/2. So now you may remember that in the unit circle, sine is actually the y coordinate. So because you want to find the places where sine x equals 1/2, so this is like saying y is equal to 1/2. So you want to find out in the places in the unit circle where y is equal to 1/2. So if you take a look at the unit circle, you will notice, okay, that there are two places where y is equal to 1/2. One place is right here. Can everybody see that? Okay, and that angle is pi over 6. There's another place where y is equal to 1/2, and that's this place where y is equal to 1/2. And the angle there is 5 pi over 6. And there are just two angles. For example, if you look at here, then y is not equal to 1/2, but y is actually equal to negative 1/2. And here too it's equal to negative 1/2. So if you just look at y is equal to 1/2, there are only two places. This angle pi over 6 as well as this angle, which is 5 pi over 6. So in other words, there are only two angles for which sine x is equal to 1/2 in the unit circle, and those are these two angles, pi over 6 and 5 pi over 6. So our answer for the step 2 of that, which is to find out the places in the unit circle where y is equal to 1/2, there are two answers, pi over 6 and 5 pi over 6. So now we are done step 2. And step 3 is, if necessary, find all solutions. Now look at the question now. Do they want you to find all solutions? No, actually they only want you to find the solutions between 0 and 2 pi. So 0 is 0, 2 pi is 360. So they actually want you to find only the solutions between 0 and 360. So that means they only want the solutions in the unit circle which we have found. And the two solutions are pi over 6 and 5 pi over 6. So our answer is actually pi over 6 and 5 pi over 6. That's our answer. Okay. Now let's go on to, so once again, the 3 steps are, first of all, you isolate the sine on the left hand side, or the trig function, whatever it is. and then you look at the unit circle and you find out, depending on the trig function, what are the solutions in the unit circle. So usually there are two solutions in the unit circle, and then you write them down, and then you check whether they are asking you to find only the unit circle or everywhere. So here they want only the unit circle, so the answer is that we have these two solutions. The answer, we have two answers, x equals pi over 6 and x equals 5 pi over 6. Now let's look at the second question. The second question, they ask you to find all solutions of 2 cosine x minus 1 equals 0. Alright, so they want you to find all the angles satisfying this equation. So first step is to isolate the trig function on the left side. So how do you do that? Okay, so now it is not isolated because there is a negative 1 and a 2. Can you see there's a 2 here and there's a negative 1 right here. So first of all, you need to take the 1 over to the other side. And then when you do that, you get 2 cosine x equals 1. You add 1 to both sides. But still, the cosine is not isolated. It comes with a 2. You need to get rid of the 2. So to get rid of the 2, you need to divide by 2. So you divide by 2, you get cosine x is equal to 1/2. Now, you have cosine x is equal to 1/2. So now the trig function is isolated on the left hand side. Now you need to find two places, the two places in the unit circle where the cosine x is equal to 1/2. Cosine is the x coordinate. So you want to find out where the x coordinate is 1/2. So let's find out where the x coordinate is 1/2. So if you looked at now here is the x coordinate is not 1/2. Here it is not. But certainly here the x coordinate is 1/2. But where else? Now is it here? No, here the x coordinate is negative 1/2. So here the x coordinate is 1/2. There's one more place, and what's that? That's in the fourth quadrant, and that's right up here where the x coordinate is 1/2. So there are two angles, and the two angles are pi over 3. And then what's the other angle? 5 pi over 3. So at 5 over 3 and 5 pi over 3, the x coordinate is 1/2. That means cosine x is equal to 1/2. So the answer to step 2 is pi over 3 and 5 pi over 3. 5 over 3 and 5 pi over 3. But that's not the end of it. Now you go to step 3, right? And you took a step 3, and in step 3 you will see, so this is, you can think of this as step 2, what we just did, right? Let's put that step 2 actually. Step 2. Now let's do step 3. You need to look at the question and see what they're asking. If you look at the question, it says you to find all solutions, not just the solutions in the unit circle. Now what do you mean by all solutions? Now we already have two solutions. One is pi over 3 and the other one is 5 pi over 3. So let's concentrate on the pi over 3 solution. Okay, now if we start from here and if you go around one whole circle and come back here, again when we hit this point we get cosine x to be equal to 1/2 because the coordinates of this point is 1/2. So even if you go one whole round, but the angle then is not 60. If you go one whole round and come back, then the angle is 360 plus 16. In other words, it is not pi over 3, it is 2 pi plus pi over 3. And if you go one more, then you get what? 4 pi plus pi over 3. And if you go another one, you get what? 6 pi plus pi over 3. Okay, so you can keep adding 2 pi's. 2 pi plus pi over 3 is 4 pi's, 6 pi, 8 pi, 10 pi. You can keep adding 2 pi's to your original angle and you get a new angle. In other words, you keep adding circles to your original angle. So for pi over 3 you get, so in general it can be written as pi over 3 plus 2 pi times k. K can be anything. So if k is 1, then you get 2 pi, k is 2, you get 4 pi and all that. You can do the same thing for this angle. So it can be pi over 3, it can be pi over 3 plus 2 pi, that is after one revolution, pi over 3 plus 4 pi after 2 revolutions, 1, 2, and if you go 3 revolutions, 1, 2, 3, you get 5 pi over 3 plus 6 pi. Again, you can write this as 5 pi over 3 plus a multiple of 2 pi. For each revolution, you get a 2 pi. So do you notice that in general, the two angles can be written as the original angle, which is pi over 3 and 5 pi over 3, plus 2 pi times k. So if for different values of k, you get different angles. For example, if k is 1, you get 2 pi here and you get pi over 3 plus 2 pi. And if k is equal to 2, you get 2 times 2 pi, which is what? 4 pi. So you get 5 pi over 3 plus 4 pi, and so on. The same deal for this. You can get your original angle 5 pi over 3, or 5 pi over 3 plus 2 pi, or 5 pi over 3 plus 4 pi, or 5 pi over 3 plus 6 pi. So in general, all you do is, it is very simple. In step 2, you find the two angles, and then you just add a 2 pi k. So you add a 2 pi k to pi over 3. So it's pi over 3 plus 2 pi k. And you just add a 2 pi k to 5 pi over 3. And then you get 5 pi over 3 plus 2 pi k. That's it for this video. And we will see you in class. Bye.